The first step when you digitize an image is to establish an origin. So in this case, the origin is the marker on the far left-hand side, and you want to draw a line that's perfectly horizontal from that marker. And then you want to add another line that's going to be perfectly vertical from that marker. The next step is to prepare your participant. So in this case, we're interested in the location of the ear and its movement through time, and the angular displacement at the knee. So first thing I'm going to do is actually going to place this marker directly on the ear. Obviously mine's quite large compared to what you should have made yours, but it gives you an idea of the marker or the point that we're interested in. Your next step is to determine your scaling factor. So I'm going to use this white square here as a fake ruler. There are two markers at the bottom of the screen, but in your case, you might actually have a meter stick in your image that you can measure from one end to the other. In my case, a meter is the distance between the middle of this marker to the middle of that marker. So I take my ruler and I measure it out. Let's say that I measure it out as being 12 centimeters. Well, that represents the measured distance. That's the distance that I measured using my ruler. The actual distance in real life was 1 meter or 100 centimeters. So to come up with my scaling factor, I can take 100 and divide it by 12. It's 100 centimeters divided by 12 centimeters, which cancels out the units. So my scaling factor actually does not have units. It's 8.3 in this case. That means whatever distance I measure on my screen, I just have to multiply it by 8.3 to know the distance in real life, not just on the image. So I can place my ruler here from the vertical axis to my marker. Notice how my ruler is horizontal. What that means is that whatever I am measuring is a horizontal value, a horizontal displacement or position in this case. Another way to put this is px. So I am measuring the px as being, let's say, 5 centimeters from my axes. Well, that's right on my image, but that's not the value in real life. I wasn't just 5 centimeters away from the marker. To figure out the actual distance, I have to take this 5 centimeters and multiply it by my scaling factor. My answer is going to be in centimeters because that's the unit in my equation. So I end up with 41.65 centimeters. That's how far away I was from the origin. I can then do the same for the vertical position. So in this case, I need to flip my ruler over and go from the horizontal axis up to my ear. So I go to the middle of the marker. Notice how my ruler is vertical? Well, that's because it represents a vertical position, or PY. So I measure, let's say it's at 18 centimeters. To get the actual distance in real life, I mean, I'm not 18 centimeters tall, I'm much taller than that. You want to take that 18 centimeters and multiply it by your scaling factor. And that gives you a value of, let's say, 149.9 centimeters. Another way to put this is 1.499 meters, if that's just more intuitive for you. And there you go. You've just digitized the horizontal position and the vertical position of my ear. In the question, I had asked for the angular position at the knee as well. Well, the angular position at the knee requires that you have 3 markers. One of the markers will be at the hip, joining up to the knee. The other marker is going to go from the knee all the way down to the ankle. You then need to take a protractor to measure the angle between those 2 segments. So I won't be able to superimpose a protractor on this image, but essentially what you do is you place the joint here on this X, and then one of your segments, so you could say the thigh, up on the 0 line. Then from here, you traverse the numbers until you get in line with the knee angle. So in this case, it could be roughly 160 degrees. There you go. You've calculated the angular displacement at the knee. You digitized.